All right, so we're going to look at number 16, and I just want to remind you, right, if you think about what these exponents mean. So again, this is a power, right, of a power. So it's a power of another power. And this means 6 squared to the 4th power. So 6 squared multiplied 4 times in a row. So 6 squared times 6 squared times 6 squared times 6 squared. Right? And then if we think, what does this mean? Well, that is 2 6s multiplied in a row. So, right? So each one of these is 2 6s multiplied in a row. And then we would, if we wanted to, we could count them up and say, okay, now we have 2, 4, 6, 8 of them. But, right, if we can remember how it works, and the rule, and it makes sense if you think about it, right? 4 2s, 2 times 4, right? So 2 times 4, this is a multiply sign in here, right? Then this is going to be 6 to the 8th power. All right, what about the other example that we did? So again, this is a product and this is a power. So this is a power of the product. And so we want to think to ourselves, so first of all, we could have done it, I didn't expand it out, but this means this, all of this multiplied 3 times in a row. So we could have said 8 times 12 times 8 times 12 times 8 times 12, right? We could have multiplied each one out, and then you can see there's 1, 2, 3 8s multiplied in a row, so 8 to the 3rd times 3 more 12s, 12 to the 3rd. Right, so we could have thought about it that way, right? But the rule is that you just multiply by the exponents that are already there. There's a 1, right? So this is 3 times 1, or 8 to the 3rd, and 3 times 12, which is 8 to the 3rd. All right. So you have to think to yourself, why might I want to do that? And also, when can I and when can I not do that? So let's look at these examples down here. So looking at number 18, all right? So I look at 18, I think to myself, okay, the directions say simplify. How can I do that? So first of all, I notice this is 6 to the 0 power, right? 6 to the 0 power is 1. And 1 times anything is itself. So now I can ignore that. So I'm going to show you the first step is, this is now 6 to the 9th times 6 to the 9th times 6 to the negative 10. And so now I can see that this is a product with powers. And so my rule is that I'm going to add those exponents. So I have 9 positives and 10 negatives. So that's going to leave me with 1 negative. And then I could leave it like this, or I could remember that this means division and write it as 1 over 6. I can have it 6 to the 1st power, but I don't need to. It's the same as 1/6. All right. When you look at number 20, I feel like they're trying to trick you because they just told you about this product of a power, this power of a product. But notice, this is not a product. This is subtraction. You cannot do anything. You have to subtract first. So 10 minus 6 is 4. And then now this is 4 to the 3rd times 4 to the 2nd, right? Plus, right? What they're doing here is they're saying, okay, this is going to be 12. So 12 to the 2nd power. All right, I'm going to move this onto another sheet of paper because sometimes this is what happens in math is they expect you to notice something and you have to think to yourself, well, how would I notice that? It just is one of those things. Some people pick them up a little bit more quickly. Okay, so first, this is plus. Can I do anything here? No. So order of operations say exponents and multiply, but we know there's a rule that if these have the same base, that we can combine them, right? So this is 4 to the 3rd, like this is 4 times 4 times 4 times 4 times 4 plus 12 squared. Well, guess what? These are all multiplied in a row. The rule is that we add those exponents. This is 4 to the 5th plus 12 to the 2nd. And we can't do anything else unless we start multiplying it out. So if we're asked to simplify, we stop here, and that's it. So this is going to be 4 to the 5th plus 4 squared.